Okay, so on question 4, it's a question under groups. Here we have been given a set S defined by the elements 2, 4, 6, 8, even numbers, and an operation star. Okay, now let me ask you to complete the table below. So we have our operation star, we have 2, 4, 6, 8. Then we have the same elements here, 2, 4, 6, and 8. Now, they say we are going to, and the operation is being defined as multiplication under modulo 10. What does it mean, multiplication under modulo 10? It therefore means that if I multiply two elements, if the result is greater than 10, I will therefore take that element and divide by 10, and the remainder that I'm going to put in the table. So I have 2 times 2 is 4. I put here 4, it's not up to 10. 2 times 4 is 8. And I have 2 times 6 is 12, and 12 is greater than 10. So I take 12 divided by 10, give me 1 remainder 2, and I put 2 here. Then I have 2 times 8 is 16. I have 16 is equals to 1 remainder 6 under modulo 10. So I put 6. So I have here the same, I have 8, and then I have the same thing. I have here 2, and same, I have 6. Now, I can feel the other ones. I have 16, I have 6. With this one, I'm going to have 24, which is 4, and I'm going to have here 32, which is 2. Now, I'm going to have, so that way I'm going to complete this other element. I'm going to put 4. Here I'm going to have 6, and here I'm going to put here 8. Same, I'm going to have here 2, then I'm going to have here 8, and I'm going to have here 4. So those are the elements. So like you can see, the group is closed because there's no addition of any other element. All the elements we have in this online table are elements that belong to a set S, and so the operation is closed. So now, the next question we are being asked is to find the identity element. The identity element E is an element such that A star E, that is A star is equals to E star A, which is equals to A, where A is any element in the set, that is 2, 4, 6, or 8. So now we are going to have this. From the table, we can see that all elements are multiplied. 6 is the identity element because all elements are multiplied by 6. Like let's take this row here. This row here, I'm going to have 2 times 6 gives us 2, which is giving us back 2. And then I have here 6 times 4 is giving us 4, which has given us the element back 4. We have 6 times 6 is 6, and 6 times 8 is 8 again. So it means that this element E is equals to 6. Now, we have to determine the inverse of each element. The inverse of an element is A inverse such that they have A star A inverse is equals to A inverse star A, which is equals to the identity element E. And to find the identity element E is very simple. To find the identity element E, and we already know the inverse of the identity element is the identity element itself. Okay, and it's very simple to do that. You just need to come and spot the spaces where we have 6 on this table. Look at, you take 2 elements and if the result gives you 6, it means that one is the inverse of the other. For example, 2 times 8 gives us 6. So this one means the inverse of 2 is 8, and the same thing, and the same way the inverse of 8 is 2. So it means that what? The inverse of 8 of 2 is equals to 8. Now the inverse of 4 automatically is going to be 6, because we are going to have the inverse of 4 automatically is going to be 6. So the inverse of 2 is 8, and then I have here, I'm going to have I have 2 equals to the inverse of 4. The inverse of 4 is 4 rather. Excuse me, because we see here we spot our 6. We have 4 times 4, we have 6. Each place where we have 4 times 4, we always have 6. And then the inverse of 6 itself is 6, which is identity element. And please don't see because you have 4 times 4 giving you 6, it means 4 is identity element. No, it's the only condition that satisfies the identity element is when you multiply each of the numbers of the set and it remains unchanged. That's why 6 is the identity element and not 4. In a similar way, now we're going to go to the second part of the question. They say the transformation t of x defined by xy is giving us 2x minus 3y and x plus 3y. Okay, now say write down the coordinates of a point t 3, 4. So we have the point 3, 4. Point P made of 3, 4. That means t of 3, 4 is going to be what? You replace 3 in the place of x and you replace 4 in the place of y. So similarly, it's going to give us what? What are we going to have? We're going to have here 2 into 3 minus 3 into 4, comma, we have here 3 plus 3 into 4. So we have t of 3, 4 is going to be 6 minus 12 gives us negative 6, and then we have here, we're going to have 3 times 4 is 12 plus 3 is 15. So that's the inverse of that element. So we're going to move on to the next question, the next part of the question. That's the B part of the question. Now the B part of that question, remember one question 4. The B part of the question, they say, write out 2 by 2 matrix representing the transformation T. Okay, we know that to have let's say, let the images, let capital X and capital Y be the images of small x and small y under the transformation T, under T. So it therefore means x is equals to 2x minus 3y, and half capital Y is going to be x plus 3y. So we see we can make this a matrix in a matrix form. We're going to have this, and I still write it in this way: capital X and Y, and excuse me, you have x plus 3y equals to y. So you see that I can write in this formula like this, where I'm going to take only the coefficients. I'm going to have 2, 1, negative 3, 3, and then have x, y equals to capital X, capital Y. So the matrix M, the 2 by 2 matrix M is given by 2, 1, negative 3, and 3. That's the matrix we're being asked to look for. Okay. Now we're going to move on to the next part of the question. That is the C question. They say, we have been asked to find the invariant point under this transformation. The invariant point under the transformation is a point xy, such that if I take t, such that t of xy is just going to give us xy. What does that mean? It means that the points don't change. For example, if I have here, I'm going to take if I take this one, I'm going to take 2x minus 3y equals to x. For me to determine the invariant point, it means that if I take x and replace in this transformation, I'm going to have the same value x. If I take y and replace in the transformation, I'm still going to have the same value y. So I can solve this equation. I said this becomes a simultaneous equation. This is same as x minus 3y equals to 0, and I also have here x plus 2y equals to 0. From here we see that from the second equation I have x equals to negative 2y. And from there, if I can replace x equals to negative 2y in the first equation, so I'm going to have here negative 2y minus 3y equals to 0. This means y equals to 0. And which also means, since x is equals to negative 2y, means x will also be 0. So the invariant point is 0, 0. We'll have the point 0, 0. And it is clear because if you take 0 and replace in this transformation, you see we are going to have 0 for x, and the y coordinate is going to be 0 also. So we'll move on to the next question, which is question 5. Okay, question 5. We have been asked, they say find the range of values of x for which you have the absolute value of 2x minus 3 is less than or equal to 2. And this definition, the definition of absolute value is negative x when x is less than 0. And it is x when x is greater than or equal to 0. So from there, this therefore means that absolute value of x lies between, which is this, is similarly It similarly means that 2x lies between negative 2x minus 3 lies between negative 2 and 2. And so from here, this becomes an inequality which we can solve. So if we take this other part, if we add 3 to both sides, we're going to have negative 2 plus 3. And we're going to have 2x less than 2 plus 3. And from there, we're going to have here positive 1. And we'll have less than 2x less than 5. So we can divide all through by 2. And remember, we don't divide inequalities. We don't divide inequalities by negative numbers. Less is going to change the direction of the inequality. So yes, since 2 is a positive number, therefore means we can divide. So I'm going to have here a half less than or equals to x less than or equals to 5 on 2. So the range of values is x lying between a half and 5 on 2. Okay. Now, let's say P and Q. Let's go to the next part of the question, the Roman 2 of the question. Okay. We're being told that P and Q are the points of intersection of the curve with x squared minus 9 and y equals to x minus 3. So find the coordinates of a point, the coordinates of P and Q. To find the coordinates of the point P and Q, we just need to equate the two equations. We're going to have x equals to that. Now we can solve this. This becomes a quadratic equation. We're going to have x squared minus x, and then we're going to have this way 3. We're going to have 6, negative 6 rather. So we're going to have here, we can factorize this. If we factorize this, we're going to have this plus 2x minus 6. So this is the same thing as saying x minus 3 into x plus 2. Yeah. So equals to 0. And then we have therefore means x equals to 3 or x equals to negative 2. So x equals to 3 corresponds to the first point P. So when x equals to 3, what happens is that the value of y becomes, you can also place here, either of the two equations is going to give us the same thing. So we're going to have here 3, we have 0, y becomes 0. When x equals to negative 2, when x equals to negative 2, we're going to have here negative 5. Any of the equations in which you replace, you're going to have the same value. So the value, the P and Q will have coordinates 3, 0, and Q will have coordinates negative 2, negative 5. Okay. So now we're studying the coordinates of P and Q. Okay. Now we want to also calculate the length of the line PQ, which is the next question. The B part of it is saying we should calculate PQ. PQ, as we know, is the square root of x2. Let me just call it like this: xq minus xp all squared plus yq minus yp all squared. This therefore means we have the square root of xq, which is negative 5 minus xp all squared plus xq, yq rather. Any of them, in any order you should add. If you add the yq, then just okay. Let me just do it like I've written, so it will not be confusing. So I'm going to take xq minus xp. So I'm going to have here negative 2 minus 3 all squared plus yq. Where, like we were saying, we're solving additional maths 2018, and we're at question 5, and more precisely at the B part of the question. We're being asked to calculate the length of the segment PQ, of the line PQ. That is, we gave the formula which was xq minus xp all squared plus yq minus yp all squared. We should calculate it, so that's going to give us negative 5 squared plus negative 5 squared is going to give us 25 plus 25, giving us 50, square root of 50. And square root of 50 is equals to 5 root 2. So the segment of the line PQ is equals to 5 root 2 units. So let's just put units, because here we don't know in what units they were measuring the coordinates.